Hi everybody. Since I won't be with you in lab this week, I wanted to make you a video showing you what you're going to be doing. If you get stuck, absolutely let me know. If you do get stuck, please send me a screenshot of where you're stuck at so that I can try to figure out what's happening. So this week, you guys are going to be calculating different biodiversity measurements and graphing them. And so this first video is going to be about how to do the calculations, and then the second video is going to be about graphing. We are going to work with the Camera Trap Excel workbook, which is going to be the same workbook that you guys used last week. So if you can find that workbook, awesome, go ahead and open it. If you cannot find that workbook, don't worry, you can download another copy from the Moodle lesson. But either way, you want to get that workbook somehow and open it, and you should be on this worksheet. I have a couple of other tabs because they're going to be for stuff I'm going to show you later, but you should open it on this worksheet. You will be unsurprised to learn that the first thing that we're going to do is make a pivot table. Pivot tables are just a really good way to help organize and see what's happening with really large data sets, and that's what we have. So hopefully you remember from last week that the first step in creating a pivot table is to choose the data that you want. We want all of the data, and so I'm just going to click this little triangle between the A and the 1, and that will choose every single cell in the worksheet. Then I'll go up here to Insert and insert a pivot table. I want it in a new worksheet, so this is great, and I'm going to push OK. So for today, the first pivot table that you're going to make is going to be a nested pivot table that will have vegetation type and then species nested within that. So you can click them, which I think that you guys know. I actually don't normally click them. I don't know why, I just didn't learn that way. I normally grab them and drag them down here. So either way is good. So you'll have vegetation type as your primary row label and then species nested within that. And then we're going to grab species count down here for the values section. Hopefully you guys will remember from last week that count is basically the frequency at which the animals are seen. So there were 9 pictures taken of aardvarks. That may or may not mean that there are 9 aardvarks, depending on how many are in each picture. And so to get the actual number of animals, we cannot use count, we have to use sum. So if your pivot table puts up count automatically, you'll need to change it, which you can do by clicking this little down arrow, come here to Value Field Settings, and choose Sum. Okay, so now we've got our pivot table. Hopefully, you guys remember paste values from last week, which is how we can copy things out of the pivot table and then paste them in a text-only format. We are going to use that. So a lot of you are awesome at mousing. I am not as good at mousing as you, actually. And so I don't use the mouse for this part. I use the Shift key. So the Shift key tells the computer to keep what I've already got selected and then to add more stuff to it. So one option is I'm going to hold down the Shift button, and then I'm going to use the arrows to arrow over and down until I get all of the stuff in the floodplain section, but nothing else. Okay? Then you can come up here, choose copy, or you can use Control-C. Then I'm going to come here, go to paste, and choose paste values. Ta-da! Okay, I'm going to do this example only with the floodplain grassland, but I do want to show you copying and pasting the limestone gorge as well, so I can show you where to put it and show you a different thing about copying. So to copy the limestone gorge, I'm also going to click here. Another way that you can use the Shift button is, so I've got the top left cell that I want. I can then just scroll down. If I hold down the Shift and choose the bottom right, cell in the selection that I want, Excel will automatically choose everything between that. So then you can use the copy command or Control C to copy. You're going to want to put this 4 columns over. This is the thing I wanted to show you. So then you'll come up here to paste values, because we're going to want these 2 columns for calculations actually, and then I like to leave a buffer column so that I don't get confused. Okay, so now we're going to work in this floodplain grassland, and then after you guys watch this, you can do the same thing on the other 3 vegetation types. So before we can start to calculate the biodiversity measurements, we need to make some edits to our data. The first thing we're going to do is delete out the humans. So the camera definitely captured them, but we would not consider them to be like a part of the ecosystem. And so, I mean, they are, but anyway, we are deleting them. We do not want to capture them and calculate them as part of our biodiversity. So we're going to delete humans. The next thing that we need to do is do something with lions. So all of these other rows are each one species, okay, except for the lions. And so the camera classification has lion cubs, lion females, and lion males. And we need to collapse that all down into lions. And so you have 2 options. Option 1, you can add these together in your head, which is easy because it's 3 plus 2. But you'll get some bigger numbers later on. So option 2 is to type you in a formula. So you'll start with the equal sign and then do 3 plus 2, enter. Either way is good. Then we're going to delete all of the other lions. We only want 1 lion row to begin with or to end with. And then we're going to delete this classifier because now this is all of the lions and not just the lion girls. All right, so hopefully you guys have done that. Delete people and then consolidate lions. The next thing that we need to do is recalculate the sum of the individuals. So this 18,639 is directly from here, but it includes people. And so I'm going to delete that. And then I'm going to go up here to formulas. We're looking for the sum formula. You can either get it in auto sum, the sum, or you can get it in math and trig and scroll all the way down to the S section. Either way is good. So then I want to re-add up all of the animal numbers since I've deleted humans. So I'm going to do the same thing that I showed you with the gorge. I'm going to put my cursor in the first box, scroll down to the last one, hold down the shift button, and then click, and Excel will choose everything in there. And so by deleting people, we have gone from 18,639 to 17,881. That's not the important part. The important part is that that's the accurate number of how many animals we have. So now we can start to look at our biodiversity measures. The first one is abundance, which is how many individuals we have independent of their species. So abundance is going to be 17,881. I do not want to retype that in case I type it wrong, like the number version of misspelling. So I'm just going to push equals, and I'm going to come up here and click this cell, and Excel will just copies the number down for me. So this is how many total non-human individuals we have seen. Okay. So the second thing to calculate is species richness, right? Which is how many different species we have. This is why we had to consolidate the lions. So I'm going to make myself a little heading, and then this is going to seem weird. We're going to actually make a pivot table of this summary data. Excel does not have a good built-in way to count number of different words. We are not going to count this by hand. We want the computer to do as much as possible because we are very likely to miscount, skip stuff, count something twice. So we want the computer to do it. The way that we can do this is to use another pivot table, actually. So we're going to highlight just this data, because this is all that we want. I'm going to come here to insert and insert a pivot table. But this time, I do not want it on a new worksheet. I want it on an existing worksheet. In fact, I want it right there underneath my species richness label. This is going to be a really small pivot table, so don't worry. Okay. So then what I want is a count of how many things are in the floodplain grassland. So I'm just going to take floodplain grassland, pop it down there into values. My version of Excel defaults to count. If yours does not, you'll need to change it. And it tells me that there are 31 things within floodplain grassland. Super. Now I don't need to count them by hand. Okay. So the next thing that we're going to calculate is Simpson's index of diversity. There are a whole bunch of different diversity calculations. So it's important that you call it Simpson's index of diversity every time. You don't just call it diversity. All right. So this is the pollinator calculation thing that we did for the example. And so I have copied and pasted this, and I'm just going to scooch it over here so that I can remember what I'm doing. Scooch it over there. Okay, so I see that I need n minus 1, n and n minus 1, which is the number of each animal type. Then I also need capital N and capital N minus 1, which is the total number of individuals, and then that minus 1. And so I'm just going to label this N, although it actually means it can be capital N as well. Then I'm going to scooch over 1, and I'm going to label this N minus 1. And then I'm going to label this N times N minus 1. So I'm going to put formulas into each of these that will help me calculate this. And I'm doing the labels first to keep track. So here, I'm going to put the equal sign, and I want this cell to have that cell minus 1. Okay? And then here, I want this to be my number times my number minus 1. Okay. And we'll come back and highlight these in a second. Then we're going to use the awesomeness that is the fill handle. And so, oh, crisis. We're going to choose these two cells, and then we're going to use the fill handle. You come over that little square in the bottom right, and you just hold down and pull, not that far, until you get to where you want to go. And then you let go, and it will drag the formulas down for you. So this is one reason that it's really good to use cell references in formulas instead of actual numbers, because then as you use the fill handle to drag the formula, it will update as it goes. Okay, then I'm going to come back to these three, and I'm going to highlight them yellow. You can bold them, whatever, to remind myself that these are the capital N ones. I did not do that first, because if I had previously highlighted them yellow and then used the fill handle, everything that I dragged down would also have turned yellow. So that would have been a problem. Okay, so I'm going to look at my handy dandy copy and paste thing, which I will put for you guys in the lesson, but then of course you can see it here. And so the Simpson's index of diversity is going to equal 1 minus the sum. So, sorry, you can use the formula and then the auto sum. Since it's easy to remember the command for this, which is just sum, I normally type it in. If you do type it in, then you have to put a parentheses after that. And so what we're going to get is the sum of n times n minus 1, which is going to be this last column. And so again, I'm just going to click one cell, hold down the shift, and click the other end of the range. I am not choosing this bright yellow one because it's the capital N. Okay? So then I'm going to close that parentheses, and then this is going to be divided by, I'll just scroll back down so you can see, capital N times capital N minus 1. And so I think I'm short of parentheses. There we go. Okay. So then underneath the divided, I'm going to choose the capital N and then finish out. You can see that when you make the matching parentheses, like it goes bold so you can keep track of where you are. Then I'm going to push enter. So my Simpson index of diversity is 0.8, which is really good. 1 is the most that you can get, and so 0.8 is a pretty good diversity. And then the last thing we are going to calculate is evenness, which is there the same, basically, is there the same number of individuals of each species? I do not have this formula memorized either, but I have it very handily stashed here. So I'm going to grab that and bring it, not there, over here with us. Okay, so when I click out of this cell, I want it to show me the formula. I don't want it to try to calculate something. And so you can put a single parentheses in front of the equal sign will tell Excel that this is not a formula, even though it has an equals in it. So this is my formula I'm going to use. So evenness is going to be equal to the Simpson index of diversity divided by 1 minus 1 divided by the species richness, which I'm going to click on this, but this is part of a pivot table, so it's going to give me this pivot table formula. This is totally fine. I'm not bothered by this. Just going to carry on, make sure that I close all of my parentheses, which I have a bajillion, and then push enter. Ta-da! So my evenness is also quite high. Evenness also goes from 0 to 1, and 1 is complete evenness. And so those are the 4 values that you'll need to calculate for each of the vegetation types: abundance, species richness, Simpson index of diversity, and evenness. So I'm going to stop this video now and let you guys do that, and then I'll make you another video about graphing.